Hello, welcome to eDufundae. I'm your lecturer for this topic, chemical equilibrium and acid base. When I am talking about chemical equilibrium and acid base, previously we have learned about the Lee-Chatelet principle. Today we are discussing about the application of Lee-Chatelet principle. So first of all, question will be arise that which of the following are application of Lee-Chatelet principle from the previous knowledge. So first, manufacture of ammonia by process, as we have learned previously. Manufacture of sulfuric acid by contract process. Manufacture of nitric acid by declined and high process. Manufacture of nitric acid by Ostwald process. Manufacture of ozone of Simmons and ozonizer. Scattering of ice. So these are all the processes from previous knowledge we have seen. This process obey the Lee-Chatelet principle. The answer is follows these. Industrial synthesis of ammonia by Haber process. Ammonia can be synthesized from nitrogen-hydrogen reactant in Haber process. The following reaction represents the formation of ammonia N2 plus 3S2 say 2NS3. Reaction is in equilibrium, delta is negative minus 22.2 kJ. For the reversible reaction N2 plus 3S2 say 2NS3, delta H is positive because its reaction is reversible. The equilibrium constant Kc equals to NS3 का whole square N2 और की concentration और H2 की concentration का cube. Concentration equals to moles by volume. तो NS3 की 3.6 into 10 to the 8 at 25 degree Celsius. The larger the value of Kc indicates that all the N2 and H2 have to be converted into ammonia. Because मैंने पहले भी बता रखा है कि जितना हम Kc ज़्यादा होगा रिएक्टेंट से प्रोडक्ट उतना बनेगा, उतने से ही मेरे पास रिएक्टेंट से प्रोडक्ट बनने का टाइम बहुत जल्दी कंप्लीट होगा. रिएक्शन मान लो N2 और H2 रिएक्शन है, तो अगर कोई भी अगर मान लें हम Kc की वैल्यू ज़्यादा है तो पहले अगर कोई रिएक्शन Kc की वैल्यू कम होती तो रिएक्शन कुछ इस तरह से फ्लो होती. पर जैसे ही हमने क्या बोला कि Kc की वैल्यू ज़्यादा है तो रिएक्टेंट से प्रोडक्ट बनने की जो कंडीशन हुई वो क्या होगी, पहले से बढ़ गई और प्रोडक्ट से रिएक्टेंट कंप्लीट होने में टाइम ज़्यादा लगेगा. ज़्यादा मॉलिक्यूल्स प्रोडक्ट से रिएक्टेंट में कन्वर्ट होना शुरू हो जाएंगे. ये ग्राफ आपको बाद में ही समझ में आएगा, बट मैंने आपको एक हिंट दे दिया. However, the thermodynamics factor Kc does not tell how fast the reaction can occur. According to Lee-Chatelet principle, formation of ammonia is possible at low temperature as the forward reaction is exothermic. But at low temperature, the reaction occurs so slow that no measurable ammonia is produced within a reasonable time and attain equilibrium very slowly. To increase the reaction, an optimal temperature has to be maintained. Catalyst Fe may also be used to increase the rate of reaction even at relatively low temperature. Promoter MO or K2O and Al2O can be used to increase the efficiency of catalyst. The number of moles of the reactant is 4, while that of product ammonia is only 2. Therefore, according to Lee-Chatelet principle, delta and G value 2 minus 4, that is minus 4, that is negative. Thus, increase in the pressure increase the product formation by shifting the equilibrium. Hence, high pressure such as 200 to 500 atm is applied in manufacture of ammonia by Haber process. The optimum conditions are pressure is 200 to 400 atm, temperature is 725 to 775 Kelvin, catalyst is Fe iron, O2 से 2NO, delta H is positive here. An electric are convert N2 and O2 of air into NO. 2NO plus O2 से 2NO2 बनता है. NO is oxidized to NO2 by A. 4NO2 से O2 plus O2 plus 2H2O लिया हमने, 4HNO3 बनता है. Temperature at 3000 Kelvin. Thanks for watching eDufundae and visit our website www.edufundaventures.com.